Hello everybody, this is Digital Blackboard by Sachin P. Nagmute. In this video, we are going to discuss topic solve problem on superposition theorem. So this circuit is given and using superposition theorem, we have to find current through 1 ohm resistor. So this 1 ohm resistor is connected over here and we have to find out the current of it by using superposition theorem. Now in this circuit, if you observe, there are three sources, this 1 ampere current source, this 3 ampere current source and this 4 volt voltage source. So if you want to find out the current flowing through this 1 ohm, we have to consider one source at a time. So in step number 1, we will keep 4 volt active. It means 4 volt acting alone. So if we are considering only this 4 volt voltage source, then we have to deactivate this 1 ampere and this 3 ampere current sources. Now let us mark two terminals A and B across this 1 ohm so that we can find the direction of current. And in first step number 1, we will name the current through this 1 ohm resistor as I dash. Now we have to find out this I dash. So let us deactivate this 1 ampere current source. So it will be open circuited because it is current source. This 3 ampere will be also open circuited because it's a current source. Now this wire is no longer in the circuit, needed in the circuit, so we can cut it. So this wire can be removed. Similarly, this 3 ohm resistor is also no longer in the circuit, so it can also be cut from this point. Okay, so now we can see what will be the current. So current will leave from this 4 volt battery. It will flow through this 2 ohm and this 1 ohm. So 2 and 1 ohm are in series. So this I dash will simply by using Ohm's law, we can find out I dash is equal to 4 upon 3. So 4 by 3. So we got I dash is equal to 1.33 amperes. And the direction of this current is from A to B. So we have noted down this direction. So step number 1 is over. Now in step number 2, we will consider 1 ampere acting alone. So this 1 ampere current source is acting in step number 2. So we have to deactivate this 3 ampere current source and this 4 volt voltage source. Again, we are marking the terminals A and B, and the current name will be now I double dash because we are in step number 2. So let us deactivate this voltage source. So 4 volt is a voltage source, so that has to be short circuited, and this 3 ampere is a current source, so it has to be open circuited. So this is like this. The circuit become like this. Now the same circuit can be drawn like this. Okay, now we have to find out the current I double dash. Now let us see how current will flow in this circuit. So current will come from this 1 ampere current source, and how much current will leave from that 1 ampere current source? 1 ampere, because the current which is leaving from the current source is fixed. So as the value of this current source is 1 ampere, so 1 ampere current will come to this point A, and at this point A the current will get divided. So one current will flow through this 2 ohm and it will go to the negative, and second current will go through this 1 ohm and it will go to the negative. Now after observing this circuit clearly, we can see that 1 ohm and this 2 ohm are in parallel, and in this parallel combination the current which is getting divided is 1 ampere. So simply by using current division rule, we can find out this I double dash. So I double dash will be 2, that is resistance of opposite branch, upon 2 plus 1 addition of both the branch resistors, and volt multiply with the total current, that is 1. So 2 upon 3 into 1. So finally we are getting this I double dash is equal to 2 by 3, and 2 by 3 is nothing but 0.666 ampere. And again the direction of this I double dash is from A to B. So we have noted down the direction as well, that is A to B. So step 2 is over, we got I double dash. Now let us jump on to the step 3. So in step 3, we will consider this 3 ampere current source only. So this 3 ampere is acting alone. So we have to deactivate this 1 ampere and this 4 volt voltage source. Now again we are marking the terminals A and B, and now the current name will be I triple dash. Now we have to find out this I triple dash. So let us deactivate this 1 ampere. So it has to be open circuited, and this 4 volt will be short circuited because it's a voltage source. Now again we will see how current will flow through this circuit. So current will leave from this 3 ampere current source. So 3 ampere current source will give us 3 ampere current. So this 3 ampere current is now flowing through this 3 ohm, and it is coming to this point A. Now after coming to this point A, it will again get divided. So one current will flow through this 2 ohm and it will go to the negative, and second current will flow through this 1 ohm, that is our I triple dash, and it will go to negative. So simply by observing this circuit, this 1 ohm and this 2 ohm are again in parallel, and the current which is getting divided between this parallel combination is 3 ampere. So again we can use current division rule. So I triple dash will be equal to 2 upon 2 plus 1 into 3. So we got 2 by 3 into 3. So finally I triple dash is coming 2 amperes. And again the direction of this I triple dash is A to B. So we have noted down the direction of current. So we are done with all the three steps. So let us find the current in all the three steps. So we got I dash, we got I double dash, and then we got I triple dash, and direction of these three currents are from A to B. It means the same direction is same for this I dash, I double dash, and I triple dash. And hence is step number 4. According to superposition theorem, the total current through 1 ohm resistor is I dash plus I double dash plus I triple dash. So finally we are getting 1.33 plus 2 plus 0.66 is equal to 4 amps, and that is from A to B. So we got the total current flowing through this 1 ohm using superposition theorem. So I hope that you understood this problem very well. So like, share and subscribe Digital Blackboard. Thank you very much.